Hello, let's go over these warm-ups. In the first one, the easiest way is to factor by what multiplies to negative 10, because you would take 1 times negative 10. So what multiplies to negative 10 and adds to be 3x. And those two numbers have to be either a 2 or a 5, and so we're going to have negative 2, positive 5 to add to be 3. Negative 2, positive 5, and to just realize what bottoms up does, you divide by the leading coefficient, which is 1, and reduce. So notice how, wait a second, when we learned this, we had something times something gives us a 0. Well, in order for that to be this parenthesis, how could this parenthesis represent the 0? So one of our answers has to be 2 in order for that parenthesis to be 0. And then for this, if we wanted this entity to be the 0, we would need negative 5. So our two answers is 2 and negative 5 in the first one. In the second one, I would use square root method because it's not a difference. So hopefully you didn't put x minus 8 times x plus 8 because it's not a difference. So I'm going to move 64 to the other side by subtraction. And then take the square root of both sides. When that happens, be sure you include the plus or minus. And notice that we have the square root of a negative 64. To represent that negative as a square root, this becomes plus or minus 8i. We will go over homework answers when I return to class, or actually after the entire lesson we'll go over homework answers. So let's go to notes. If you could pause the video so everybody could get out something for notes. Today we're learning the method completing the square. So we've learned factoring, we've learned the square root method, we've discovered complex numbers, because sometimes we're going to get a square root of a negative number, and now we're learning a new method where we might get some i's also. And we're going to use completing the square, which it's helpful to write equations in vertex form, so that way we don't have to use that formula to find the vertex form, that negative b over 2a. So here's what it is. It's a process that allows you to write the expression of the form x squared plus bx as a square of a binomial. So we can find immediately what the vertex is. The trick or the algorithm is we're going to take this b, divide it by 2, and then square it. We're going to add this value to the end of the expression to figure out how to complete a square. So let's just practice finding how to complete a square. We're going to find the value of c that makes the expression a perfect square trinomial. Then we're going to write the expression as a square of a binomial before we solve. We have to learn this skill before we start solving. So let's say we have the problem x squared plus 6x plus c, and substitute teacher, if you could pause the video at any time just to help students get any kind of writing down. So in this process is I'm going to take this 6, divide it by 2, and square it. Well, 6 divided by 2 is 3, so I'll take 3 squared, and what would complete this square is a 9. So I'm going to rewrite this. I'm going to rewrite this where I'm going to put 9 in the C position, and this actually is a perfect binomial square. Here's what I mean. It's something in parentheses being squared. If I were to factor this with, what multiplies to 9, adds to 6, it would be a 3 and a 3, and they'd both be positive. Well, another way to write that is just x plus 3 squared. Let's try it again. Let's say I have x squared minus 12x plus c. I'm going to take that b coefficient, divide it by 2, and square it. So negative 12 divided by 2 and square it. My bad. There should be a negative here. But negative 12 divided by 2 would be a negative 6. But negative 6 squared, or 6 squared, they come out to be the same thing, 36. I'm going to use that 36 and put it in C's position. And this can be rewritten as a binomial being squared, just like before. What multiplies to 36 adds and gives you negative 12. It would be negative 6 and negative 6. Or I could rewrite it as something being squared where I have x minus 6. Let's try it one more time. Let's say I have x squared plus 2x plus c. I'm going to take this middle coefficient, divide it by 2, and then square it. So 2 divided by 2 and square. Well, 2 divided by 2 is 1, and then I'll square that. What would complete this square is a 1. If I put the 1 in place of c, that's going to turn into, well, what multiplies to 1 but adds and gives you 2? It's a positive 1 and a positive 1. So this will turn into the binomial x plus 1, quantity being squared. What's nice about this is if I can do this in a problem, I could use the square root method to get rid of this and solve a little bit easier. So let's solve. Solve by completing the square. Let's say I have something that looks like this. I'm going to get the 9x squared minus 18x on one side so I can figure out how to complete the square. I'm always going to move this random number to the other side. Let's see how this plans out. Again, substitute. You might have to pause a lot after each step. So the first thing is move the constant to the other side. So I'm going to have 9x squared minus 18x equals to negative 5. The second step is to complete the square, having something in front of the x squared is difficult, so we're going to divide everything by that leading coefficient 9. And when I say everything, I also mean over here on this side. So divide everything by the leading coefficient a. When that happens, we get x squared minus 2x equals negative 5 ninths. Now let's talk about completing the square. If I took that middle number, divided by 2, and squared it, so negative 2 divided by 2 is negative 1, squared is a 1. I'm actually going to add 1, not only over here, but whatever I do to one side of an equation, I'm also going to do it to the other. So we're going to add half the middle term squared to both sides, which is 1. So I add 1 to both sides, and then I now have a perfect square. What multiplies to 1, that adds and gives you negative 2. It's negative 1 and negative 1. So I'm going to write the left side as a perfect square, turning it into x minus 1 quantity squared equaling, well, let's simplify that right-hand side, equals 4 ninths. This is going to continue on a new slide. Well, my bad. Take the square root of both sides because you have something squared. And when you take the square root, we get x minus 1 equals, don't forget the plus or minus, square root of 4 ninths, square root of 4 became 2, square root of 9 becomes 3. Now I'm going to continue on a new slide. This is what we just had, and we're going to solve for x, so we're going to add 1 to both sides. And when that happens, now we are going to take 1 plus 2/3 and 1 minus 2/3 to see what our two solutions are. When you add, we get 5/3, and when it's subtracting, we get 1/3. We're going to try this again. Solving a quadratic if the coefficient of x squared is 1. So let's say we have this type of problem where we have x squared minus x equals 1. I gave myself a little room because when you have x squared and x on one side, let's complete the square so we can use the square root method. My bad, let me back up, because if you took negative 1 and divided it by 2, that's a negative 1/2. If you square that, if you took negative 1/2 and squared it, you actually get a 4th. So technically, I'm going to be adding 1/4 to both sides, so that's why this popped up. Adding 1/4 on this side completed the square. So now you write this side as a binomial squared, and we simplify the right side. Wait, what multiplies to 1/4 but adds and gives you negative 1? This is kind of difficult, but it's actually negative 1/2 and negative 1/2, which can be written as x minus 1/2 quantity squared, and the right side equals 5/4. Know that in homework, I'm never going to give you something that you'd have to figure out that deals with a fraction. In homework, you're just going to be dealing with integers. But we can finish this out. You need to be aware for any kind of ACT reasons that these can pop out. Now I'm ready for the square root method. I take the square root of both sides. X minus 1/2 equals plus or minus, wait a second. Square root of this fraction, I don't know the square root of 5, so I just write it as square root of 5. Square root of 4 does become 2. And don't forget your plus or minus. Well, now the last step is just add a half to both sides. So x is going to equal 1/2 plus or minus square root of 5 over 2. And since I don't want to plug all this in the calculator, I'm just going to write it as 1/2 plus or minus root 5 over 2. If this was a perfect square root, I can use, if it was like square root of 36, which became 6, like, if it is an irrational number, I know I can stop. If it's not irrational, I should keep going. Yeah, you can rewrite it as just 1 plus or minus root 5 all over 2. Or you can write it as different parts. Both of these are acceptable answers. One last one. So if we have x squared plus 6x plus 5 equals 0, I need to get these two terms by themselves on one side. So I'm going to move the constant to the other side. And then I'm going to take the middle term, divide it by 2, and square it. So 6 divided by 2 is 3. Squared will be a 9. So I'm going to add 9 to both sides. Whoop. I rewrite this left side as a perfect square. And what multiplies to 9 that adds and gives you 6 is positive 3 and positive 3, which can be written as x plus 3 quantity squared. Right side simplifies to 4. You take the square root on both sides and include the plus or minus. So when you took the square root of 4, it becomes plus or minus 2. I'm going to subtract 3 on both sides. And I can take this a step further. I can take negative 3 plus 2 and negative 3 minus 2, giving me my two answers, negative 1 and negative 5.